Chapter 19 is on bivariate statistics. So bi just meaning two variables. And so we're going to start with section A, which is the association between numerical variables. So for example, say you have a discus thrower and we compare the age in years to the distance they can throw. Is the distance an athlete can throw related to their age? What happens to the distance as the age increases, and how could you graph the data to actually see that relationship, and how can we measure? So that's what this chapter is all about, is being able to see and measure this type of information. So your independent variables, usually your X, and if you notice here, the age is your independent variable, and then the distance thrown is your dependent variable. So like when you used to make your XY charts, X is independent, Y is dependent, because Y depends on X. So the first lesson, with just talking about the association, gives us a scatter plot of the information. So you can see how as the age increases, so does the distance that they can throw. So correlation is your first vocab word, and it refers to the relationship or association between two numerical variables. The first thing that we're going to always talk about is the direction. If there's an upward trend, we say the correlation is positive. If there is a downward trend, the correlation is negative. And so sometimes we'll talk about if there's an increase in the independent variable, there's also an increase in the dependent variable. Here you notice as you increase the independent variable, the dependent variable is going down. Notice these points, they're just all kind of scattered, so there is no correlation. So sometimes when there's a trend, we can talk about if there's a linear trend where it's fairly tight, going up or down. Notice these are not linear. This is more of a logarithmic relationship. We're in this class mostly going to focus on the linear, but just being able to recognize when it's not linear is important. So when we talk about strength, so there's three things. Notice direction, linearity, and strength. The tighter the points are to the line, the stronger it is. Notice this line, the points are further apart. This is a weaker correlation because there really isn't a whole lot of connection there. So strong positive, moderate positive, weak positive, and then strong negative, moderate negative, weak negative. Then finally we're going to talk about outliers. Outliers do not follow the trend. So mostly these points have a linear negative, probably a moderate strength, but there's an outlier that's not connected to the data. If we look at the opening problem, we can see there is a strong positive correlation, and it appears to be linear with no outliers. The last thing is causality. All right, so sometimes we can find a correlation, but one thing does not cause the other. So there was a study done on the arm length and running speed of young children. Just because somebody runs fast doesn't mean that it's because they have long arms. This one says the number of television sets sold in London and the number of stray dogs collected in Boston. Even though there's a strong positive correlation, one does not cause the other. So if you look down here, if a change in one variable causes a change in the other, we say there's a causal relationship. In these cases, we can say the independent variable explains why the dependent variable does what it does. And it's maybe more natural to use explanatory variable and response variable rather than independent and dependent. And that's it.